All right, so guess what? We're going to get started. My name is David Berkowitz. I'm from Montrose Environmental. The background in passive tube monitoring and field monitoring using various optical remote sensing and sensors for benzene Fenceline monitoring predominantly. My presentation today is not super technical in it's not really a super technical presentation. It's more of a history of Fenceline monitoring, kind of where it came from to how we got here today, and kind of a look at some things that kind of indicate where we are moving forward. So I want to just thank everybody for coming out and watching and listening. So with that, go ahead and kick it off. So this is just a quick outline of what I'm going to cover today. As I mentioned, it's going to be really the history of Fenceline monitoring from, kind of its inception with early passive tube research, and how community monitoring using these techniques kind of assisted with the development of this approach and implementation using EPA's Next Gen Fenceline Monitoring Initiative, putting these tools into place to really try to look at how to monitor emissions at refineries and fence lines of industrial sources in low-cost ways. Now, we're going to skip on to EPA Method 325B as one of those things that kind of came out of the Next Gen Fenceline Monitoring Initiative, kind of go through its development, how it all happened, how it all came together. And then we're going to peek at Addendum A of Method 325B, which kind of shows some information on, how these uptake rates, how the sampling rates are actually determined, and how this can be used as a tool to monitor chemicals that may not have uptake rates. And then part 3 is going to be kind of regulatory developments. We're going to look at various rules. I mean, we have RSR, which has the very first Fenceline monitoring rule. And then we've got some other rules that were proposed that include this as a component of those rules. And then we're going to look at some things kind of outside of RSR, where we're headed, and just some things. We're going to look into a crystal ball a little bit and just see, what things are going to be like moving forward. So with that, we're going to dive in here. We're going to look at the history. Back in 2004, there was a study it was an EPA ORD study by, I think it was Mantech in cooperative with Mantech, to evaluate a bunch of chemicals using passive tubes. So this was a laboratory study. It was done at various temperatures and humidities for a list of chemicals. From this, EPA looked at this and said, hey, let's put this in the field. Let's see how this works in a real world application. So in cooperation with Flint Hills Resources, who was just in here a little bit ago, on the cutting edge again. They did a year-long Fenceline monitoring program, passive tube monitoring program at Corpus Christi. Interesting. So this particular study was pretty interesting overall. I mean, it kind of showed the seasonal variation in monitoring results. It showed kind of outliers here and there, a lot of what we see with the passive tube monitoring programs today. One component that they put in place, which is pretty cool, is they deployed these passive samplers side by side with some auto GCs getting speciated benzene data. So you had hour-long averages of benzene speciated data that you would actually compare to these passive tube results for 14 days, right? So they deployed it for 14 days. And so you've got these, time-resolved benzene numbers. The R squared was 0.86, pretty decent. especially considering, you've got a time resolved application versus a 14-day integrated number. So really promising results with this. So moving forward, we go into the future a little more, June 2013 through March 2015, and put this in a community setting. In Philadelphia, South Philadelphia, 17 sites, 17 monitoring locations, 42 deployments of passive tubes, but EPA added a different component to this. They put in time-resolved, low-cost sensors. So basically, this is the birth of the S-Pod that we've all heard about, right? So, and they additionally had an open path EV-DOAS system. And with all three components here, they were just trying to say, try to figure out how to compare all these various technologies. How do they compare? Can they help us identify, issues or any kind of, out of norm thing, and identify and be able to address this in a complex airshed situation. So this was also a pretty cool study. I was involved in this study a little bit, doing some of the work, the monitoring work for EPA, and it was pretty cool study. But you can kind of see things kind of evolving over time here. So here we are, 2015. Back up a little bit, June 2014. Notice of public rulemaking, RSR, Fenceline monitoring requirement put out there. So EPA is like, okay, well, we've got this thing that McClenny worked on. We've put it out in a real world setting. It's time to challenge it some more. We want to make sure we're bulletproof when this thing actually gets passed. So there were some validation studies that my legacy company, Enthalpy Analytical, was involved in to do this. It was pretty rigorous. We're talking about, temperatures, down at 0 degrees Celsius all the way up to 120 degrees at variable humidities. And this was an interlaboratory study. There was 2 other laboratories, commercial laboratories, and the EPA laboratory participated as well. So there was some, precision, interlaboratory precision involved with both real world samples and spike samples at various concentrations for a compound list of, I think it was like 7 or 8 compounds. It's pretty impressive body of data. Really kind of buttoned up EPA's case to put this out there. So fast forward 2017, everybody needs to start monitoring. The rule passes. So this is the first federal Fenceline monitoring regulation that we've seen. And in that regulation are the first methods, EPA methods promulgated probably since the 80s, early 80s, like new methods, right? We've had, TO15A or whatever like that. These are groundbreaking, right? So this is EPA's next generation emission measurement initiative in action, right? So we're moving forward. They're taking this seriously to try to reduce costs, get more information, and ultimately put more information in the hands of communities. So, pretty groundbreaking. And you kind of see the momentum building here. So we're going to back up a little bit here to, well, it's not back up, but it's kind of simultaneously. There was an air toxic monitoring project in Louisville, Kentucky, in an area called Rubbertown. This is a chemical area. This particular area is known for a lot of pollution of various organic chemicals. I mean, it's pretty complex area. So what EPA did with this one, we see S-Pods again. They also had auto GCs and passive samplers, and they deployed them at various sites to evaluate concentrations of VOCs. Also, they had S-Pods with triggers. So the S-Pods with PIDs hit a certain threshold, opens up a solenoid valve, collects a canister. You got a laboratory analysis, speciated information to kind of go with that S-Pod. So EPA's, they're building a body of data to use for regulatory purposes moving forward. And really, this particular study, it dates back to 2000, 2001, which is, you know, a community-induced effort, collaborative effort with these four persons, agencies, whatever. So EPA, Air Pollution Control District of Jefferson County, Kentucky Division of Air Quality, and University of Louisville. So really, the community's up in arms. They're upset about their air quality, and they're being heard. So EPA actually moves forward and does this study, and they determined that there was unacceptably high levels of air toxics in this area. The APCDJC implemented what's called the STAR program, so Strategic Toxic Air Reduction Program. Pretty successful. They got a 70% drop of emission of toxic chemicals. So, you know, from there you go back to the prior slide. EPA is still looking there, right? There's still plenty to do, and this is all kind of, you know, kind of painting a picture, environmental justice, right? Industry near communities, air pollution. How do we do this? Where do we get this body of data? You know, what's the future, right? It just keeps on building, right? It's almost like a slow motion train wreck here. So anyway, EPA method 325B, we're going to move on to that. So table 12.1, it gives you a list of validated sorbents, right? You've got these compounds that were basically validated. They have data good enough to use this method to determine. It's, you know, while these are pretty important compounds, it's not all inclusive. You know, the HAP list is pretty big. EPA wants to use this tool, right? So, you know, just think about that. You've got 3 sorbents, 26 compounds or so. And then down the bottom, Carbapac X is the optimum sorbent for 1,3-butadiene, which is kind of a bugger because it has a really high vapor pressure. And so you have to have a really strong sorbent to hold on to it. And, you know, Carbapac X is a pretty strong sorbent, but you get variable uptake rates or variable sampling rates over different periods. So if you do it for 24 hours, you get one sampling rate. If you do it for 7 days, you get another. If you do it for 14, you get another, right? So just leaves something to be desired there. But the basic key to this, when you're doing this, is you got to have a sorbent that's strong enough to hold these high vapor pressure compounds, or any compound really, when you got to select your sorbent. And then it also has to be weak enough to liberate it when you heat it for analysis in a reproducible, robust way. So, and we'll talk more about this moving forward. Just kind of talking about the passive tube uptake rate studies, benzene, BTEX. We briefly discussed this back several slides ago with the EPA RSR. A lot of work done on that. TO15, or I'm sorry, 1,3-butadiene, as we discussed. A lot of work was done with that. The original draft rule included an uptake rate for 1,3-butadiene in it. But further studies in 2017 kind of showed that that particular compound left something to be desired. So there was some pretty extensive research that was done on that compound, and that yielded that information. TO15 list basically, you know, just took a whole bunch of compounds, you know, threw it at the wall, see what sticks. So that information was generated. A lot of questions surrounding that information, but that is kind of a body of data that can be used moving forward. Just, hey, what's feasible? What can we investigate more? What did we get with that? And in 2021, Montrose did a study for chloroprene following the procedure in EPA method 325B addendum A, and determined an uptake rate for chloroprene. And we're going to kind of go through what addendum A is here in a few minutes. But in talking to EPA, they have a specific wish list. They have a lot of wish lists, right? But, you know, ethylene oxide, we've all heard about ethylene oxide, right? So that's something that they're very interested in having done. Like 1,3-butadiene, pretty high vapor pressure compound, and it's not really an ideal candidate for passive tubes because it's reactive, has high vapor pressure. It really needs to be trapped in a kind of a derivatization or altered kind of method. Vinyl chloride as well, compound that's of great interest, a high pressure compound. So that one's a challenge as well. And also when you heat it, you get thermal breakdown products, which kind of lends to some questions about the data. And then on the other end of the spectrum, you have naphthalene, very low pressure compound. So that creates some challenges there as well. So you have to have, you can trap it pretty easily, but getting it off and actually in a reproducible fashion, that can create some issues. So things to think about with these things moving forward and how these uptake rates are used, developed. So going to Addendum A, Addendum A is procedure attached to method 325B that must be followed to determine a validated uptake rate for any chemical that doesn't have one published either in the method or available in peer-reviewed journal. This particular picture over here is from EPA. It's from the method, but this is actually, I've been to EPA and seen this. It's like a giant racetrack, takes up most of a room. It's actually very, well, it's huge. So basically, you expose tubes, you determine the uptake rate through measurement, right? Empirical data. You compare, you generate an RSD of those data values, and you compare it to a theoretical number of what was put in the chamber. In a nutshell. So 8 levels, 2 different levels. First level is 2 to 5 times the detection limit at ppb to low ppb levels, and then the second level is the middle of the calibration. So you're kind of got to look at this for what is this going to be used for, to determine what's mid-level calibration, what's the rule or what's the purpose. So that has to kind of be determined. The atmosphere in the chamber has to be between 35 to 75%, and the temperature has to be within plus or minus 5 degrees of 25. And then the final criteria for this to work is your uptake rate must be greater than or equal to 1/2 of a mil a minute. And we kind of skip backwards to our sorbent selection question here. So your uptake rate is affected by back diffusion and the ability to reproducibly and completely get your compound off the tube, right? So it has to be suitable. So that's the final check there. This picture over here is our exposure chamber. It's not real pretty, so I don't have all of it in there, but that part on the right is the exposure chamber. There's another one in there on the other side, and that's a stainless steel humidifier. This box can be closed. There's a Peltier heater cooler in there, so you're able to drive your temperature, monitor humidity, and introduce your gases. It's a pretty cool little system. So we're going to talk about chemical sector, Fenceline monitoring, and rules that incorporated Fenceline monitoring requirement in them. So such as ethylene production. There was some rulemaking or discussion of rulemaking for the ethylene sector back in, I think, 2017, 2018, for the ethylene sector. EPA wanted to impose Fenceline monitoring as part of that MAC rule. A lot of discussion between the trade group, the ethylene trade group, and EPA, and that was actually removed when the rule was published in 2019. There was no Fenceline monitoring requirement, but you can kind of see EPA's, desire to implement this as a tool to get more information and notify communities. So then skip over to organic liquid distribution, OLD. This rule was proposed in 2019. It provided this as an option, wasn't a requirement, but the option was either to add connectors to these facilities LDAR programs, or to conduct ongoing Fenceline monitoring program. The kicker here is OLD isn't for benzene necessarily, right? You've got who knows what, right? So does the method support it? Well, it might, but what would you do if it didn't? This really didn't have a huge impact because I think all of them, I don't know of anybody who elected to do the LDAR, the Fenceline monitoring program, but enhance their LDAR program. I think for two reasons, right? I think from a cost standpoint, they ran the numbers, and it just wasn't, it wasn't a winner to do that. Plus, I think the liability of generating that data when they didn't have to was something on their mind. So just things to think about, but it's another indication of kind of where we are, where we're moving forward. So consent order. This is something EPA is doing a lot of, regulating via consent order. So the ethylene sector, well, they thought they got rid of it, but I think almost all, if not all of them, are now negotiating or finalizing or have finalized consent orders that incorporate this as a requirement. So the one benefit to them is that, it's 3 to 5 years, there's an off ramp, right? Where the refinery sector rule, you've got, this is in perpetuity. There are some options in there to kind of reduce your burden. What I know, not a whole lot of folks are really seeing that off ramp develop for them. So anyway, there's an off ramp here. And then fluoroprene, like I mentioned, that uptake rate that we worked on is actually being used in a consent order program. And I think we're going to see a lot more of this. Recently, Section 114 information request was put out for chemical manufacturers. Typical 114s require, the information they ask for is permits, source information, process information, and a lot of times there's testing that's involved. Typically, this is source testing, right? Stationary source testing. If you're in industry, you're familiar with this process. This one was interesting because it included fugitive emissions monitoring testing, right? It included testing. But this is Fenceline monitoring, right? Passive tube monitoring and TO15 monitoring for a select group of chemicals. So we're moving forward. This is going to be used for rulemaking. You can kind of see it. It's coming. More and more of this is coming. It's just snowballing. So state regulations. So, I've covered a lot of things with, passive tubes, sensors, and various things. California, if you spend any time in this room, and I think my friend over here is probably going to discuss some things in California here in a little bit, but basically, they're all in, right? Community standpoint, they're doing optical remote sensing out there. BAAQMD Rule 1215 and South Coast Air Quality Management District Rule 1180, optical remote sensing networks, open path programs. These are designed to put more information in front of communities about their air quality. Expensive programs to operate, but as we all know, California's usually first to the table, and things kind of flow down from there. So this may be even further out in the crystal ball, but just something to kind of think about. Also, Colorado, House Bill 1189, smaller group of chemicals, more focused. This is something that's out there, floating out there too. Montrose is assisting some folks with that. Staying in Colorado, Colorado Reg 7. This is an interesting rule where it asks the facility to develop a monitoring plan to reduce emissions of their operations, right? So that they can incorporate various technologies. Montrose is doing a bunch of work here. Things that we are using are low-cost sensors and passive tubes in tandem with a platform similar to what's, I don't know who was here for the Molex presentation, but it's basically similar to that. You got an algorithm, you got wind data, you've got sensor data, and some of our customers, we're working with them to see if we can actually help them eliminate doing an LDAR, side-by-side LDAR to sensor platform thing to reduce their burden there. So, but the passive tubes are in there, so you got your time resolved versus your passive monitoring. And then we go all the way up northeast Maine. This is interesting. They got Chapter 171 has a passive tube requirement, Method 325A, 325B, but they also have a tank seal inspection requirement in that rule. The idea really is to reduce and provide some visibility to the communities near these terminals. These are all terminals. So just, again, things to think about. In my state of North Carolina, there's also terminals out west that are being, enforcement is out there with sensors and passive tubes as well. So, these things, enforcement, they're using these tools. EPA is gathering information, rules are coming out, more and more and more things coming. And this is my last slide. Federal regulations, things coming. The Build Back Better rule bill, section 3106, has funding in the order of $122 million to deploy, integrate, support, and maintain Fenceline monitoring. This is community monitoring. Associated with this, there should be, a public platform, public-facing platform with information, data, visibility to the public. The Public Air Quality Act of 2020, introduced to the House, includes Fenceline monitoring as a requirement, methods 325A, 325B, I think TO15 is mentioned in there, sensors. So basically, all these things, these lower cost things, really the goal here for them is, responding to communities' desire for more information about the air that they're breathing. And, as regulatory or industry members, you're used to satisfying EPA and regulations. I think the thing that we need to just think about is pretty soon it's going to be beyond that. It's going to be satisfying communities that you're near. And these are all indications of kind of what's coming and how these various tools will be implemented and the limitations and implementation of a custom solution to kind of satisfy these things. There is no one catch-all. Various tools need to be used to accomplish this. And with that, I open it up if anybody has any questions. Yes, sir.
Thank you. That was great.